Hi everybody, this video is going to focus on function operations and how multiple functions are going to relate to each other by adding, subtracting, multiplying, and dividing them, and how that domain is going to change as well. But first I want to talk about some basic vocabulary. And this vocabulary can be found in section 2.1 of your book as well as in the glossary. The function rule represents an output value in terms of an input value. In other words, when I plug in an x, I get a y, and I get exactly one unique y. The domain is going to be the input values, those x values that you're substituting in of the ordered pair. Okay? The range is going to be the set of all output values, or the y values of the ordered pair. So the question here says, why can't -1 be included in the domain of x over x plus 1? So here we've got a polynomial divided by a polynomial. And let's just plug in -1. Okay? Let's say it is part of the domain and I substitute it in. Notice what happens. When you simplify, you get -1 divided by 0. Okay? Anything that is divided by 0 is undefined. So in other words, you can't divide by 0. Let me write that down. Can't divide by 0. It is undefined. Therefore, if it's undefined, it can't be part of the domain. Okay, so it would be all the other numbers except for -1. Okay. So function notation, you guys have already kind of, been aware of this. It's kind of like, well, if you have a y equals, how do I write that in function notation? Well, if f is the name of the function, that function notation f of x shows that the function name is f, and it represents the range values f of x for that domain of x. In other words, x is your input. F of x is the output. So if you're substituting in an x, you get an f of x as your output. So to write y equals 3x squared plus x minus 5 using function notation, let's see, y equals, it's a function in terms of x, and so f of x equals 3x squared plus x minus 5. Now, how can you tell if a graph is a function? All right, well, you guys have been doing this. You did this in Algebra 1. You've done it in geometry. And a graph is a function if for every x there is one y. Okay? So a graph is a function if for every x value there is one y value. Okay? So in other words, it needs to pass a vertical line test. Okay, so for example, this graph, is it a function? As you move your domain from -infinity to +infinity, and you use that vertical line, moving it left to right, do you hit exactly 1 point? Meaning for every x, there's one y. The answer is yes, this is a function. Okay? Is that a function? Well, no. As I move from left to right, let me grab a different color here, and I draw a vertical line, notice it hits 2 points. So that means there is not, for every x, there is not just one y. For this x, there's two y's. So this one is going to be a no, it's not a function. Here's another example. For every x, is there exactly one y? Well, no. Here's 2. So that one is a no as well. Okay. What if I did, parabola that opens up? That is a yes. As you move left to right, you only hit 1 point at a time. Okay. So how can you tell if the elements are in an XY chart? Okay. If it's a function, the domain's going to pair with exactly one item from the range. Okay, domain pairs with exactly one item from the range. All right, so that means one x value is mapped to only one y value. So let me give you a table of values here. Let's say I have the point -3, -2, 0, 1, and 4, 7. -3 maps to -2. 0 maps to 1. 4 maps to 7. Notice, for every x value, it maps to only one y value. Okay. Let's go with another table here. Let's say you have the point 4, -1, 8, 6, 4, 1. Okay. True that the 4 maps to -1, but notice it can also map to this one because of this guy. The 8 maps to 6. Since this 4 repeats in the x values, that means one x value has two different y values. This is not a function. So the first one is a yes, and the second one is a no. Okay. So now we're going to consider more than one function at a time, and we can add, subtract, multiply, and divide these functions. So at the top, these are your function operations. Notice the f plus g of x is the same as f of x plus g of x. When I take f minus g of x, that's the same as taking f of x minus g of x. When I take f times g of x, that's f of x times g of x. And when I divide f divided by g, that would be f of x is divided by g of x as long as, since we have a fraction, we have to watch for red flags, as long as that denominator does not equal 0. Okay, so the domains of your sum, difference, product, and quotient are going to consist of the x values that satisfy both f and g. Okay, and you also have to consider the quotient. So when you look at the quotient of g of x, it can't be 0. All right, so let's take a look at this first problem, number 7. It says, let f of x equal x squared plus 2, g of x is x minus 6. You're finding f of x plus g of x. So in other words, notice I have my f function. I'm going to add to it my g function, x minus 6. Okay, so here is the f of x, and this one is the g of x. Now, when you combine those two, I'm going to have the x squared plus the x, and then I have 2 minus 6, which is a -4. That is my new function. Okay, you're just combining functions. Looking at problem 1. If I have f plus g, well, that is the same as taking f of x plus g of x. F of x is 2x squared plus 8. G of x is x minus 3. Well, that's the same as 2x squared plus x plus 5. Okay? So I'm going to box that one in. And for f minus g, well, that's the same as taking f of x minus g of x. So I'm taking 2x squared plus 8, and I am subtracting this x minus 3. So notice you have to distribute that negative, minus x plus 3, and that's going to give you 2x squared minus x plus 11. Now let's talk about the domains. When we look at the f of x, it is a parabola that opens up, and I know the domain for a parabola that opens up or down is -∞ to infinity. Now, g of x is x minus 3. That is a linear function. Its domain for any line, increasing or decreasing, that domain, as long as it has a slope that's increasing or decreasing, positive or negative, it will be a -∞ to infinity. So what is the domain of f plus g and f minus g? Well, it is the intersection of those. Where are they? Both. What are the domains of both? So that's going to be -∞ to infinity. So let's talk multiplying and dividing. So if I have a new function here, f of x equals 3x squared minus 11x minus 4, and g of x equals 3x plus 1. Circle f times g. All right, so that means you're taking the f of x function and you're multiplying it by the g of x function. Let me rewrite that. Times the g of x function. All right, so f of x is 3x squared minus 11x minus 4, and g of x is 3x plus 1. So those are written as quantities. If I'm taking f divided by g, that's the same as f of x divided by g of x. Okay, well, f of x is the 3x squared minus 11x minus 4, and the g of x is 3x plus 1. So I'm looking to divide those two. Now it says to simplify the product. When I have this, the 3x squared minus 11x minus 4 times 3x plus 1, I'm taking 3x squared times that entire binomial, and that would give me, what, 9x to the third. And then 3x squared times 1 is 3x squared. Now take negative 11x times the binomial. Negative 11x times a 3x is a negative 33x squared. Negative 11x times 1 is negative 11x. Take the negative 4 times the entire binomial. You get negative 12x minus 4. All right, so what does that equal? That equals 9x to the third minus 30x squared minus 23x minus 4. Okay. Now it says to simplify the quotient. Well, when I'm looking at this quotient, 3x squared minus 11x minus 4 over 3x plus 1. What you're looking at is to simplify the numerator. What are the linear factors? That's what you're looking for. That factors into 3x plus 1 and x minus 4. And you can choose to factor by grouping. You can slide divide bottoms up to figure that out. Over the quantity 3x plus 1. Here's what I see. The 3x plus 1 over 3x plus 1 cancel. That cancels. And that leaves me with an x minus 4. So what's the domain? Actually, you know what? Let me go to 17. For what values of x does g of x equal 0? Well, g of x is 3x plus 1. When does it equal 0? Well, when x is negative a third. The domain of f times g. Okay? The domain of f, well, the domain of f, let me write it to the side here, is negative infinity to infinity. Domain of f. The domain of g, well, it's a line, negative infinity to infinity. So the intersection of those, where they are, what are the domains of, what are in the x values that are in the domains of both, that's going to be all real numbers, negative infinity to infinity. So f divided by g, it's going to start with all real numbers, but denominator can't be 0. Well, when does 3x plus 1 equal 0? Well, we just did that number 17 at negative a third. So all real numbers but negative a third. So that means negative infinity to negative 1/3 union negative a third to infinity. Okay. Let's do a few more examples of that division. Actually, that's the exact same equation. Let's switch the equation. Okay. So let's say, I don't know why I wrote the exact same thing down, but it's how the day's going. Let's say we got 2x squared plus 8 and x minus 3. 2x squared plus 8 and x minus 3. So that goes from that first example, that problem 1, but this time we're going to do the multiplication and we're going to do the division. Okay, so first thing, this f times g is the same as f of x times g of x. My f function is 2x squared plus 8. My g function is x minus 3. If I multiply those two, well, multiply your first terms, 2x to the third. Multiply your outside terms, negative 6x squared. Multiply your inside terms, plus 8x, and your last term is a negative 24. So what is the domain of this? Well, let's see. The domain for the f function is negative infinity to infinity because it's a parabola that opens up. And for g of x, x minus 3, that domain is negative infinity to infinity because it's a positive sloped line. So the domain, the x values that are in both f and g, is negative infinity to infinity, all real numbers. Now if I'm doing f divided by g, that's the same as f of x divided by g of x. So f of x is 2x squared plus 8 over x minus 3. So here's what I see. The numerator, let's see, it can factor. That would be a 2, x squared plus 4 over x minus 3, that quantity. All right, so there's my f divided by g. Notice that the sum of squares does not factor. And if I'm looking at the domain of this, it's going to be negative infinity to infinity, so all real numbers, but not what makes the denominator 0. What makes the denominator 0? 3. So everything but 3. Negative infinity to 3, union 3 to infinity. What happens, though, if I would take g divided by f? Well, that would be g of x over f of x. So g of x is x minus 3. F of x is 2x squared plus 8. Okay? And that factors into x minus 3 over 2 times x squared plus 4. Again, can't factor any further. But here's what I want to know about the domain. The domain. Well, it's going to be all real numbers, but what makes the denominator 0? Well, look at this 2x squared plus 8. When will it be 0? Plug in a negative number. I don't care what negative number. And negative squared is a positive times 2. Well, that's still a positive number. I get a number. Add 8. I still get a number. Okay, so all negative numbers are part of the domain. How about 0? Is it part of the domain? 0 squared 0 times 2. 0 plus 8. Yes, I get 8. 0 is part of the domain. How about any positive numbers? So if I have a positive, I don't know, a million squared, well, it's still going to give me a positive number times 2, still give me a positive number plus 8. So when it's still giving me a positive number, when will this denominator be 0? This denominator will never be 0. It will always give me a positive number. So that means the domain for g divided by f is negative infinity to infinity. Okay, so anytime you've got that fraction, you want to verify the domain by checking the denominator, okay? Because that denominator cannot have a value of 0. All right, that's going to lead us to composite functions. So a composite function is a combination of two functions so that the output of the first function becomes the input of the second. All right, so I kind of drew a little diagram. So if I have an input, some x value, I'm plugging it into the first equation, I get an answer which is my output. That answer becomes the input for a second equation. Once I input it into the second equation, I get an output for the second equation. That output from the second equation is my final answer. So the composite is a combination of those two functions. Okay? So let's take a look at it in some algebraic way. So if I say I have a composite of the function g with the function f, it's written g, notice the open circle, little open circle f, that means g composite f. I could also say that's g of f of x. Notice it can be written g parenthesis f of x and parenthesis. So what happens is that you would want to evaluate, start with your parentheses, evaluate f of x first. So take the x value, plug it in f. get an answer, take that answer, and it is substituting into g. So you're going to use the answer, which was the f of x, as your input for g. Okay, whatever you get once you do that, that's your final answer. You can also do the composition in the other direction. So the composition of the function f with a function g is written f composite g. So that is f of g of x. Notice what's in the parentheses. We would do the g of x first, take the x value, plug it into g, get an answer, and then substitute that into f. So that means the output then becomes the input of the second equation. So g of x is the input that goes into f. I take that answer, put it into f, evaluate it, and whatever I get in the end, that is my final answer. That is the composition of the functions. So I've got an example here where I have two functions, f and g, and I want to do a few compositions with that. Okay? So I have f of x is x minus 5, g of x is x squared. All right, so if I have g composite f of negative 3, this is the same thing as g of f of negative 3. So when you think of your order of operations, I need to figure out what is f of negative 3. So I'm going to substitute f into, or negative 3 into the f equation. So f is x minus 5. I'm substituting in negative 3. Negative 3 minus 5 is negative 8. So now I'm finding g of, well, what was f of negative 3? Well, we said it was negative 8. That is where the output becomes the input for the second equation. Plug negative 8 into the g equation. The g equation is x squared. Something squared. I'm plugging in negative 8. Negative 8 squared is 64. My final answer is 64. Okay. Let's take a look at number 2. Notice this is f composite g of negative 3. That is the same as f of g of negative 3. So I'm finding g of negative 3 first. I'm taking negative 3, substituting it into the g function. The g function is x squared. I'm plugging in negative 3 squared. Well, that's 9. So now I'm taking the 9 and I'm substituting it into the f equation. Well, it's something minus 5. Well, 9 minus 5 is 4. So a couple things that I want to point out. I plugged in negative 3 both times, yes? But notice, these are not commutative properties. I can't take the composite in each direction and get the exact same number. Okay? So this does not satisfy the commutative property. So let's take a look at number 3. Notice I'm doing g of f of x. So I'm trying to write the new function. So let's see, g of f of x. Let me write that down. All right, well, let's see here. G of, what is f of x? It's x minus 5. So this x minus 5 is what I'm inputting into the g function. Well, that's something squared. Well, what am I plugging in? I'm plugging in x minus 5. I'm plugging in f of x. So that is x minus 5 quantity squared. Expanding that, putting it in standard form, x squared minus 10x plus 25. Okay, there's my function. Let's do the composite in the other direction as well. F composite g of x. That is the same as f of g of x. So in other words, I'm taking g and plugging it into the f function. Well, let's see. What is g of x? The function is x squared. So I'm taking the x squared right here and plugging it into f. Well, f is x minus 5. What am I plugging in? I'm plugging in x squared. So that is x squared minus 5. Notice, when I do the composites in both directions, it is not commutative. I'm not going to get the same answer. All right, guys, hope that helps.